last week we left off after finding that our data has a lot of zero wind directions. We'll find out how to fix it in this week's MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. This week, I want to continue talking about how we deal with missing data or bad data, or maybe just data that's not encoded like we expect. And we started to see this when we looked last week at our histogram of wind directions, and we saw there were a lot of zero wind directions, and it turns out they corresponded to zero wind speeds. So as it turns out, these data are encoded when no wind reports a zero direction, and if there's wind out of the north, it reports a 360. So what are we going to do about this, or do we need to do anything about it? Well, my favorite thing to do in Python when I don't know how something's going to behave is to write a toy example, because Python makes it so easy. So I'm going to create an array called myData, and we're going to go ahead and make sure we have NumPy imported as well. And this array, I'm going to have some zero values and some non-zero values. And I want to see, well, does this affect things like calculating the mean? Well, okay, we know it's probably going to affect the mean. If I calculate the mean of my data, say I want to know the mean wind direction, if these are wind directions in my example, okay, it's telling me 57 degrees. Now, what if I replace the zeros with not a numbers, saying, well, there's no wind, so it doesn't have a direction. I'm going to do that by finding where my data is equal to 0, and using that to index into the my data array, and setting those values to NumPy's NaN object. Now if I calculate the mean of my data, I get NaN, because it doesn't know how to deal with NaNs unless I use NaN mean, which says, well, ignore the NaNs. And then I get a reading of 200. So a very significant difference in my statistic on wind direction. So let's look at our real data now. My DRCT data series, I'm going to call the .describe method. And we can see we have 347,398 readings with a mean of 128.12 degrees. So now, what if I replace all of those with all of the zero wind directions with NaN? So to do that, I'm going to set the directions equal to direction with the replace operator. I'm going to replace 0 with np.nan. Now there are some changes coming up in Pandas 3 that we'll talk about in the future, where normally I would use the in-place argument here instead of reassignment, but that is going to change in Pandas 3, and so I'm doing this to kind of future-proof this. Okay, so we've now done that operation. Let's issue describe again. Now we see we're down to 235,087 readings, and our mean direction has shifted by quite a bit. Now we're at 190 instead of around 130. So that could really mess with your statistics if you weren't paying attention and had done some of this data exploration and handling missing, malformatted, or just the complexities of our data. If we want, we can go ahead and make a histogram, because now we're not going to be looking at that big bar of zero wind directions. We might actually get a better idea of what's going on with our distribution, and we see the most common being southwesterly winds, though everything is relatively even-footed here. Now, before you go off and use NaN to replace all the data that you believe is not valid or not a number, as it suggests, we need to talk about some of the behavior of NaN and really some of the behavior of the new pd.NA object, which really isn't new. It has been around since pandas 1. It is still considered somewhat experimental, but it has some nice features and some things that are different than NaN, which is why I generally tend to use NumPy NaN still, because it's still a little too much in flux for me to want to put in production code. The big disadvantage of using NumPy's NaN is that whatever the original data type of that data series is gets coerced into either a NumPy float64 or object. Whereas pandas NA will let you keep the original data type of that data series, whether it's a string or what have you. So that is nice. But I want to look at the behavior of NaN, and we'll also take a quick look at none, and the behavior of pandas NA, and compare them a little bit here. So a few good ones to know. Is none none? That does evaluate to true. What about NaN? NaN is not equal to NaN. That's an important one to remember. I've seen a lot of bugs in code from that. Okay, what about the pandas NA object? Well, that's different yet. So comparing NaN to NaN returns a Boolean. Saying is NA equal to NA returns NA. So that's an interesting and different behavior. We can check if something is a NaN or is an NA, though, by using is. So np.nan is np.nan. That evaluates to true. pd.NA is pd.NA. That also evaluates to true. So you have a variable called a. You could say a is np.nan or a is pd.NA. So let's go ahead and check some of the maybe more odd edge cases, but things that you will run into in real data. What if I take a NaN and multiply it by a number? I get NaN back. pd.NA gives me the same behavior. What if I take NaN to the 0 power? I get 1. pd.NA also returns 1. What about 1 to the NaN? Returns 1. 1 to the NA also returns 1. So far, those are very, very similar. We can also check if something is NaN using the isNA method. That works on NaN. And it also works on NA. So far, again, very, very similar behavior. One interesting exception, which we've already hinted at above. np.nan is equal to 1 is false. pd.NA is equal to 1 returns NA again. So NA does sort of fall through these comparisons, whereas NaN just returns a Boolean. So that's the main place that you'll see them not be used interchangeably. Pandas also has the not a time NAT object, which is nice because it takes the place of somewhere where you have date times everywhere else. You don't have to worry about typecasting with np.nan or getting coerced. So it is a useful tool there, but as I said, NA and NAT are still somewhat in flux, though I think as we get into Pandas 3, certainly that'll be a little bit more hammered down. And even in Pandas 2, we haven't seen large changes in them. So they're probably good to start using, but I use NaN unless the coercion's really going to cause me a problem still. The last piece of the puzzle that we're going to talk about when dealing with missing data is how we fill in missing data. But we'll do that next week. I hope that you found this useful. I'll see you on next week's MetPy Monday.